right, so this week we are going to learn how to create coding protocols, and we're also going to start our discussions of multicultural considerations for our topic. So why are we creating coding protocols? The reason why we do coding relates to what we do in a meta-analysis. And I know that you've seen this slide twice already, but it's coming back again because every time we review it, we understand a little bit more about the process, given that you're getting a little more of a piece of meta-analysis revealed to you every week. So again, in a meta-analysis, we're reviewing the literature, but then again, we're not just reviewing, we're actually creating a statistical summary of the literature. And we're also trying to identify if that effect size that we're creating is consistent or if it's inconsistent across the findings. So what does that statistical summary look like? We're going to be looking for, is it similar from study to study, or does it really vary from study to study? And we also want to be able to assess for possible contributing factors if we do find inconsistency across the articles. So if we find that the effect size really varies across the literature, we want to do some further investigating into that. If we've coded some things that can help us to look at that and see what that difference could possibly be attributed to. And there's a lot of possibilities as to how we can do that, and we'll talk about those as we continue. So, what are we going to code? The first thing that we need to code is effect size data. In order to create that statistical summary, and in order to identify if it is actually consistent or inconsistent across the studies, we have to have the effect size data because this is essentially what we're doing in meta-analysis. We're trying to look at what the effect size is through the literature and summarize that in an empirical fashion through meta. And there are a ton of possibilities with effect sizes, and so we're going to talk about these a little bit later. But our effect size data could be, as you've already seen in last week's lecture, we could have means, standard deviations, and the ends of each group. We could also have means, standard errors in the ends of each group. We could also end up with a t-value in the ends of each group. We could have a correlation R with the n, etc. A lot of different possibilities depending on the type of effect size that we're working with. So what else do we need to code? The other thing that we need to code is study data. But why? Part of this is just to be able to identify the study itself. So we need to know what studies were included in our meta. So in order to do that, we need to know the exact citation, we need to know the type of publication that it is, and we need to know the year that it was published, so the year of the publication. But we also want to be able to assess for possible contributing factors. So we'll also include study data that includes descriptors of the sample, descriptors of the research design, and then also descriptors of the treatment that was employed. So for example, treatment could differ across the samples because of a particular sample characteristic. So, treatment could be effective for one ethnicity more than another. It could also be more effective for men than for women. Treatment could also, the difference in effect size could also differ by design. So it could be that when we are looking at true experimental designs, we're not finding a statistically significant effect. But if we're looking at quasi-experimental, it seems like those articles are finding statistical significance. So we can look at some of those reasons. It could also be something to do with the treatment itself. Think about this. So, not all CBT is created alike. Not all psychodynamic therapy is created alike. So, it could be some aspects of the treatment and how it was actually delivered that's making some of these differences. So, we want to be able to code enough information on the sample, the design, and the treatment so that we can look at all of those possible contributing factors. And we want to code them, especially if we think that they're relevant to what's causing the inconsistency in the effect size. Additionally, the study data that we're going to use to identify the study, sometimes that can be really important as well. So, for instance, it could be the type of publication that's making a difference. But what's actually more often is that we'll find that it's the year of the publication. So, if we were to think about how a treatment has likely become more effective over time as it's become refined, you might find that the effect size is much stronger over time. So sometimes that could be a finding. Or the relationship between two variables has changed over time as a result of cultural trends, etc., things like that. So study data is used as a way to assess for contributing factors as well. So what else do we want to know? This is also where we'd want to look at multicultural considerations. The more that we can code about cultural groups included in that particular study, the more that we know whether or not the effect size that we end up with is actually applicable to that group. So there's a buzz right now, and there has been for a number of years, about evidence-based practice, EBPs. And though we are creating a basis of evidence for all kinds of therapeutic practices right now, a lot of those we don't actually have any culturally relevant information out there on them. And a lot of the samples that we end up looking at are, let's say, 60% Caucasian, 10% this, 10% that, 8% this, 2% that, and so on. So in the end, we might make a conclusion that we can generalize to all of those groups because they were all represented in some form or fashion in the sample. But in actuality, it might be that the 8% or the 2% groups didn't really actually have enough say-so. So being able to code more information about those groups and being able to look at that is going to be really, really important. Now, of course, to pull out those smaller groups, we're actually going to need more sample data. We need a lot more samples. We need better data in the articles than we're frequently going to actually find. One note here is that in the Lipsy and Wilson chapters, at one point they say, just say no. What this is getting at here is basically the finer detail that you try to get at, the more difficult it's going to be to find. And you'll end up with so few studies that it's probably not worth the amount of effort that it takes to code all of that data. Now, on the other side, Bornstein and his colleagues, they actually said that if you have an effect size from 2 studies, so if you just created a meta on 2 studies alone, you actually now have more information looking at them together than you ever did looking at them separate. So if it's something that seems like it would be culturally relevant and you can find it in the literature, it might be worth going ahead and coding for it. When we're talking about multiculturalism, we're not just talking about race and ethnicity. That's only part of it. I'd like to look at the definition of multiculturalism that's been published by a PA. So not only are we talking about race and ethnicity, but it goes beyond that. I'm talking about primary language, sexual orientation, gender or sex, depending on how that is described, age, disability, class status, education, religion. So there are a lot of dimensions to multiculturalism. Now, trying to look at all of those dimensions, if I wanted to look at every single one of these dimensions, I'm going to end up with a huge coding sheet that is actually pretty unbearable. And I'm probably going to end up with maybe one article in each category. So you want to be judicious in what you choose. But I do want you to think about and discuss with your group which dimensions of these seem to be particularly relevant to the topic that we're looking at. And some of these are going to be more of maybe a consideration of an exclusion factor that you set for your exclusion criteria. So if English is a second or third language for a particular sample, this might be something that you determine could actually impact their response to the treatment, because it might not impact them in the same way. So you'd want to either code for that or use it as an exclusion criteria. So remember, there's a lot of variations when looking at multiculturalism, and we're looking beyond just race and ethnicity. Something else to think about. Now, truthfully, what I'd love to know is that for someone of a specific race who speaks a specific language, is a specific age, and who is of a specific sexual orientation, etc., trying to get that kind of detail, you're going to end up with an N of 0 every single time. But if you're looking across some of these dimensions, if you could code them, let's talk about some of these things. So you're actually going to find race and ethnicity in most articles. You'll find enough information to code this dimension at least 70 to 75% of the time in articles that are that have data that was collected in the US. It's actually much less often discussed in articles from other countries. So coding information from studies from Canada, sometimes they only marginally describe the sample. So they might say there were 212 college students, but they discuss no makeup of the race or ethnicity of the sample. We might guess that it's actually pretty diverse, but they didn't mention it, so you can't code it, so it's missing data. If we were to look at age, you'll usually find age. You'll get a mean and you'll get a standard deviation to go with it. Sometimes articles will report a range, so you can code the minimum and the maximum. You'll usually find gender. And the rest of these dimensions are really going to vary depending on the topic that you're looking at and what you're going to find on any one of these. So again, think about the particular population that you're going to be looking at and trying to assess, and see if there are any of these dimensions that are more relevant to your research question. So let's go through an example. Let's stick to my running example of looking at the effectiveness of EMDR and TFCBT for children and adolescents who present with post-traumatic stress symptoms. Looking through the literature in this area, when we did this study, the estimates of treatment effectiveness actually vary. They're not consistent. So for this, we're obviously going to need basic demographics in order to describe the sample. But there are also some specifics that are actually going to be relevant to the topic. So if we're looking at the effectiveness of these two treatments and their ability to reduce PTSD symptoms over time, we're going to want to know, did the children or adolescents in the sample actually have a formal clinical diagnosis of PTSD in the sample? Or did they have subclinical levels where they just presented with post-traumatic stress symptoms? We would also want to know how much time has actually passed since the traumatic event that they experienced to when they're receiving the therapy. Let's measure that in months. It would also be helpful to know what type of trauma the participants experienced, whether or not they were diagnosed with any comorbid disorders, and if any of them were also taking psychotropic medications at the time of receiving either EMDR or TFCBT treatment. So all of these specific demographics would actually be really critical aspects to be able to look at as potential contributing factors if there is inconsistency across the effect sizes. So coding for these, you'd be able to potentially look at those factors. So let's look at what this coding sheet would look like. Now, this is an abbreviated version, but this is essentially sort of the makeup of a coding sheet. So one of the things you're going to code in the sample descriptors is sex. And you'll notice that at the top, we've got a categorical coding, and then in the middle of the coding sheet, we've got another example where you can write in the number. For sex, you can actually write in the exact percentage or N number of the males or females. It doesn't matter, whichever might be more common in your articles would be the best way to go. Usually they're presented in both ways. But I generally don't recommend writing in the exact number for ethnicity, just because a lot of the times in the articles you're not going to get that level of data. So in the first example at the top of the page where we've got sex, percentage of girls in the treatment sample, and we've got it broken up categorically, mostly what we're looking for is this primarily a male sample or primarily a female sample? So it's coded here as percent that were female. So let's think about this practically. So if I know that 0% of the sample was female, then I also know how many males there are. So therefore, it's 100% male. And that's, of course, if we go with a dichotomous breakdown for gender, which most of the research does nowadays, even though it's not actually a dichotomous area. But how that's broken down is we can categorize it into 1 being 0% female, 2 being greater than 30% female, 3 being 50% female, 4 being greater than 60% female, 5 being 100% female, and 99 representing unknown if you're unable to find that information in the article. For age, most of the time you can find a mean, and you'll also put a standard deviation with that if they provide that. And you can also code the minimum and maximum as well if you're not given a mean. For race and ethnicity, of course, this is also broken down in a similar fashion. So you've got 100% white, greater than 60% white, greater than 60% Hispanic, and so on, with 6 meaning mixed. So no predominant race would be greater than 60%. So here we're looking at who is predominantly represented in the sample, or if no one truly had a predominant representation, then you can refer to it as a mixed sample. So if it was 30% this, 30% that, 30% that, 10% that, then great, it's a mixed sample. And of course, 99 for unknown. So you'll notice that well, not everyone on this page, but every single item that you code will actually have a 99 value for unknown. If you don't have the information, you're going to put in a 99 for unknown instead of leaving it blank. And that confirms that you have actually coded that item and that you have determined that it is missing from the article. So 99 means it's unknown, it's considered officially missing data. The reason that all of these are 99, yet the mean for age is 99.99 is because most likely for mean age, I'm going to have something with 2 decimal places. So let's say that the mean age that we find in an article for a group is 22.73. So I basically just followed the same sort of pattern of what I'm likely to find in the data. So every time you find a mean, it's going to likely have 2 decimal places. You're going to match your unknown value to follow the same schema as the rest of the data that you're coding. So for the continuation of this example, we're measuring the PTSD symptoms over time and the change in those. And actually this discussion here applies to any dependent variable. But this is another piece of what's needed to code, and this is going to be true for any topic. So for the dependent variable, how this is measured is going to be very important. For PTSD symptoms, there's actually a lot of variability in how that's measured in terms of the instruments that different researchers use. And you can see here on this slide all of the different types of PTSD measures that are actually used in the literature. And I actually didn't even list all of them that we included in this project. I cut it short. You'll notice that I've also listed other at the bottom. So it's possible that we can come across other measures that we didn't expect to find and actually can clump those into a new category. So writing out the description of what the other might be becomes helpful. And you'll see that on the coding sheet on the next page for the example. So for any one of these instruments that is used to measure PTSD, you also want to consider reliability. You want to know how reliable is the instrument that they're using. And if we're using a measure that has really bad reliability, then that effect size is going to be impacted by that. So we'll actually want to look at the reliability of that dependent variable. You'll notice that I've written here that reliability can be inducted. So what do I mean by that? What I mean by that is the reliability for a test or for a measure isn't actually a property of the test itself. Reliability is actually a property of the scores that you obtain from a test. So how reliable it is within one group won't necessarily be the same or identical in reliability when it's used with a different group. So really, what we'd like to have is the reliability for that particular sample. And for the instruments that you're using, if you notice that some instruments are being used more routinely, you'll definitely want to look at how reliable those are, preferably. But the caveat with this variable, reliability, is that it really varies across the literature with how frequent researchers will actually report reliability on their particular samples. So you can find it anywhere from 20 to 70% of the time in articles. Sometimes what they'll say instead is, according to Beck, reliability for the BDI is 0.87. That's what's called induction. So they are actually using the reliability that was found during the norming of the instrument or from some other previous study that they're citing, rather than calculating that alpha coefficient for reliability for their particular sample using the instrument. So that's induction. And if that's all you have, then we have to go ahead and use that. And it's not uncommon that we just don't have that data. So this is not usually a variable that we are able to successfully look at a lot of the time, because those reporting standards are just not followed in the literature, which is really, really sad. So how does this part look on the coding sheet? Like I said before, we have several different possible measures for PTSD symptoms. We also have another category to write in and describe the measure that was used. So you see 8 represents other, and you've got that line there to write in what the measure was called. If you end up coding reliability, that would go below this, and you would code it to 2 decimal places. You would write in the alpha value, and you'll want to note how they coded it. So was it based on their sample? Was it inducted? So did they cite a previous researcher, the parent article of establishing the measure, or was it not reported, or did they just state it is reliable? So a take our word for it type of statement. The next piece that you'll need is that lovely effect size data. So let's look at some different types of effect sizes and examples. So if we're looking at a central tendency project and we wanted to estimate the prevalence of parental verbal abuse across the literature, we're basically going to need an overall N of the overall sample, and we're going to need an N of the group that ended up experiencing parental verbal abuse. If you have a percentage, you can actually convert that to an N if you know the overall N of the sample. And then if it's included, you can get at the details of any subsamples if there are any within the article. If instead we're looking at correlation and log odds ratio, data for these can actually be fairly simple. And simply because there aren't as many variations for how to calculate an effect size with these 2 types of effect sizes. And you can see those variations in the online calculator for creating that part of your coding sheet. For standardized mean difference, on the other hand, this is actually the toughest effect size because there are so many different possible ways that we can get at this data. So you can imagine that creating your coding sheet for this type of effect size is going to be challenging. So you're going to want to discuss with your group how you're going to want to do that. And you want to make sure that you're pulling the right data out of your articles in order to be able to compute an effect size. So remember, sometimes you might be pulling means, standard deviations, and ends. Other times, means, standard errors, and ends. You might have a t-value with an n at some point. So, in other words, we could end up using a lot of different types of data to pull together and then create that standardized mean difference at the end. So you'll end up coding the actual information that they give you from the article, and then you can also calculate what that effect size is and enter that in your coding sheet too. And in this process, you'll want to peek through the articles to see which ones you should be putting in your coding sheet. And we'll go over a few hints on standardized mean difference specifically. So let's look at an example of what the effect size coding would look like for a standardized mean difference coding manual. So you're going to want all of your N data, right, for each of your groups. So we start at the top with sample size. So you're going to want the overall total sample size that was at the beginning of the study when they recruited all of the participants up front. Then you're going to want both the treatment and control group sample sizes. You're going to want to know how many total left the study, so the total attrition, and then you're also going to want to split up the attrition by treatment and control groups as well. And we'll talk about why that's important on the last slide, but you will want to have that information for dropouts. And then you'll want to code the effect size data that the article provides you, so specifically categorizing that. And these are actually the most common, depending on the topic that you're looking at. We'll have to check our topic that we're going to do, but these are generally some of the most common that you will be pulling from your articles, with the exception of a few others, depending on how these articles present them. So means and standard deviations, means and standard errors, t-value, f-value, chi-square, correlation, regression coefficient, sometimes ANOVA, ANCOVA. So we'll have to look at our articles in specifics. We also want to code the page number that the effect size data was found on. Why? Because whenever we sit down to go over our initial and blind coding for the inter-rater reliability piece, we don't want to have to search for this for too much time. We don't want to waste time doing that. We want to take notes of where we found things so that we can adequately find this stuff. And we want to know which table it came from. So the more information we can write down as notes for ourselves, the easier it comes. So we actually build into our coding sheet the page number that we found the effect size data on so that we can skim to that very quickly should we need to. We want to code the outcome descriptors. So are they comparing the reduction in the level of PTSD symptoms, or are they giving a specific reduction? Are they saying this group experienced a greater than or equal to 30% remission of symptoms over the course of the treatment? More often, you're going to find it coded as a comparative reduction because they're going to compare those post-test scores and give you means and standard deviations on those. And then you're going to be coding the means and standard deviations. Now, you can also code at pretest, but the most common is just to code the post-test scores. So you write those out for the treatment group and control group with means and standard deviations. And then you would skip the last part if they don't provide you, or excuse me, if they do provide you means and standard deviations, you skip that significance test piece. But if you don't get means or standard deviations or means and standard errors, you'd skip that piece and you'd write in the t-value or the f-value, what have you, in order to calculate the effect size. And then you calculate the effect size at the end. Now, there's a couple more variables that will also be relevant that I did not include, but we will discuss those during group work. So, a couple of hints on coding. Now, you'll want to really pay attention to this slide because sometimes it can take quite a while to code articles, and sometimes you can get through an article and then realize that you didn't need to fully code it. So I'm going to give you some really awesome tips. So please pay attention to this because this will save you a lot of time if you follow these basic principles. So, and these are actually going to be helpful for when you start coding during week 5. But these are for you to think about because calculation assignment 3 this week during week 4 is actually going to be coding an article and doing a practice run through of what that process is like. And so these hints will be helpful to you starting this week. So always read the methods and results from each article that you're coding. And think about, did they look at what you're looking for? And do their operational definitions fit your problem specifications? I don't actually want you to start coding all of the sample data until you actually know whether or not it applies to what you're looking at. So I want you to start at the end and code the effect size data first. Because if what you find in the article is that there's not enough data to code an effect size, then we actually don't need to code all of the rest of our data. So start at the end, make sure you can find what you need, because you absolutely have to have an effect size for it to be included in the analysis. So if you find in coding the effect size data first that you don't have that data, again, don't code the rest of the article. You'll actually just close it up. At the top, you'll write non-codable at the top of your coding sheet, and we'll exclude it from the analysis. Third thing, please don't code in a vacuum. So what that means is use your team. If you're banging your head against a wall, remember that 2 brains are usually better than 1, but don't use your second coder. So if you're working on a particular article, make sure that it's not your blind coder that you're reaching out to for help to lean to, because you want to be coding as the initial coder, and then you want the blind coder to be blind to any of your thought process. So if you're going to reach out to someone on your team, make sure on your coding schedule that you're not reaching out to the person who's scheduled to blind code your article. And again, try to do it on your own, think it through, read it through a couple of times, take some notes in the margin of considerations, and then reach out to your team if you're stuck. And lastly, and most importantly, note where you got stuff. So this is a very technical way to say, make sure that you circle, you highlight, you take notes in the margins when you're finding things. If you're doing a full meta, think about it. It might be months before you guys finish your initial coding, move into blind coding, and then finally have your inter-rater reliability meeting where you discuss the codes that you came up with, which might differ, and you'll have to sit there and defend how you got your answer, and you might not have the slightest clue how you got that answer. And that's not a good thing, because then you're going to have to recode and rediscover your thinking process, which is very difficult when a lot of time passes. So in the inter-rater reliability process, like I said, you're going to want to understand how you coded it and how that differs from how your blind coder coded it. So you don't want to get stuck having to reread and recode. So remember, circle things that you find, highlight where the data is coming from, write notes in the margins. If you have to guesstimate something, write down your thought process and how you guesstimated that so that you can recall it for when you sit down for that inter-rater reliability meeting. That is going to be crucial to your success. Now let's talk about guessing and whether or not if it's too much guessing going on. So there's actually a definite amount of guessing that's actually going to happen when you're coding. So you'll find that people just aren't as precise as you want them to be in these articles. And doing this process of meta, you'll start to see how much data is actually missing from folks writing up methods and results sections in articles. This will actually help you to gain that critical eye in evaluating research, because you'll see, well, they didn't list the ends for each group. This is super confusing, and you will learn what to do and what not to do in this process. So you actually might find an article like one of the ones from the homework this past week. At the bottom, they reported the range of the N from 140 to 146. And so if you have that sort of N, you can go ahead and guess. I would always go with the conservative number. So go with 140 and it'll estimate the effect size a little. 146 is actually going to overestimate the effect size if it's somewhere in that range. So again, if they're reporting a small range from 140 to 146, a difference of 6 participants, then sure, that much guessing is okay in that instance. But if instead what they're reporting is an N somewhere between 40 and 100, I'm not going to guess on that because that would actually make a huge difference in the effect size. If you're not sure, you can actually just pop in to the online calculator and see what the two differences do to the calculation of your effect size. Look at it. Is it a dramatic difference? If it did change dramatically, then you probably don't want to guess. But if you're between 140 and 146, between 40 and 45, I'm going to feel fine guessing that. So, another example, let's say that you start reading in an article and they say they started with 100 people that were randomly assigned into two groups. But they never actually mention the size of those two groups. You can actually go ahead and guess that they were about 50 each. So, talking about this from a technical perspective, it's possible that they didn't actually use restricted random assignment, which actually makes equal sample sizes on both sides. They actually could have done a true random sample where they just flipped a coin. And so they could end up with 60 in one and 40 in another, or 55 and 45. But in the general sense, I'm okay with going ahead and guessing that each group had 50 in them. But let's talk about another example. So what if you had an overall N, but they said that they had two pre-existing groups? In this instance, I don't really have any reason to believe that those groups were actually equal in size. And if they don't specify, I have no reason to believe that they were equal. So you want to read through your article very carefully. You want to read through it a couple of times because sometimes you miss details the first time. Can you guess? Or is the information in a place that you didn't initially see, but can you guess? Yeah, sometimes you can guess, but make sure you write a note on the side of the article in the margin, somewhere on your coding sheet that lets you know how did you come up with that coding value so that you can remember that and then defend that later. And hands down, this is going to be some of the most uncomfortable things that you have to do is guessing with how to code some of these things. The last thing that I want to talk about today is ITT or PPA. This is something that comes up pretty frequently in the literature, and I just want to take some time to make sure that I at least initially talk about it because we'll continue to talk about it for the remainder of the term, but I want to introduce what these two things are if you have not yet encountered these in looking at literature. So ITT is intention to treat analysis, and PPA is per protocol analysis. So you'll actually see this pretty frequently in randomized controlled trials. And whether they used ITT or PPA is actually going to make a difference in the effect size depending on which one they use. And you'd want to know how the effect size is going to be affected based on either of these that they use. And if you have a topic that is coding for the effectiveness of treatment and looking at that as a whole, this is definitely a variable that you're going to want to code in your coding sheet. So, intention to treat analysis. If they randomly assign participants into two groups, if they use an intention to treat analysis, they're actually going to include everyone in both of those groups in their analysis, regardless of whether or not they dropped out of the treatment. So they're going to include people who completed treatment and dropouts in their analysis. So the people that you're looking at in the treatment group, they actually may have never attended a single session, but they're still including them in that treatment group. On the other hand, if we're looking at per protocol analysis, we're actually only looking at people who completed treatment compared to our control group who received no treatment. So why would you do either? What's the difference between the two? So for ITT analysis, the pro for this is that it actually protects against inflation of the effect size that's due to the most at-risk people. So the at-risk folks are the ones that are going to be most likely to drop out. So we get rid of them and we look at the ones who are most likely to change in treatment in the PPA analysis. But again, ITT protects against overrepresenting our effect size. In that instance, though, ITT actually underrepresents the effectiveness because we're including those folks who never attended or only attended once. How much good did we do for them? Probably not that much. So remembering that ITT analysis can underrepresent our effect size, and per protocol analysis can actually overrepresent. And so this can actually come into play in your effect size analysis. All right, so that concludes the lecture for this week. And I'll actually give you a few hints now about this week's assignments. So this week we are going to do a calculation assignment that actually gives you practice for how to code an article. You're going to code an article on looking at the effectiveness of generalized anxiety disorder treatment. And this was actually a project a number of years ago and an actual manual from a group of students years ago. So doing this calculation assignment early on this week after you've watched this lecture is absolutely critical to your success this week in developing your own coding manual for your own project. Why would you not go through the example of coding an article to see what it is that the process is like before you have to create your own, and potentially use the example as a basis for creating your own? So, hint, do the calculation assignment very early on in the week before your group work so that you have the most amount of information available to you in this process. Also, you have the discussion board that will be very helpful in determining what sorts of multicultural dimensions are relevant to your topic and what you should include in your coding manual. And I'll also be popping in and coding those as well. And then also, for your coding manual assignment for your group, while this is not on the syllabus, I have added an additional resource that is helpful to you. I know that you are reading Lipsy and Wilson chapter 4 this week, but if you'll notice in the module, I've also included Appendix E for you to look through. This is actually an example of a coding manual and coding form that gives you excellent examples of how to go about coding these things, and you can use this appendix as help to you to create your manual. Very, very helpful. Of course, don't plagiarize, but Appendix E is really, really helpful for going through that and creating your manual and coding sheet. So those are a few tips, and I will see you in the forum.